Hello everyone, Andarki Namaskaram. My name is Jansi. I am a design verification engineer. So in this video we are going to see what is an embedded system and how the embedded systems are useful to the students, and what are the career opportunities and career objectives once if you have learned the course of embedded systems. So let us dive into the PowerPoint presentation. So introduction to embedded system. So basically let me ask you one question. So if I am asking you whether which body part is important, whether it is heart is important or brain is important, we doesn't answer. For us we need both brain and heart. So in the same way the embedded system deals with the software as well as hardware. So basically the combination of software and hardware is called as embedded system. So in this video we are going to understand what is the embedded system foundation or the fundamentals and real world applications and future potential of embedded computing. So going to the next slide. So what is an embedded system? Yes, so embedded system is basically it deals with the specific task and it will do perfect with the specific task. For example, let us take washing machine. So washing machine will wash clothes only. If we see the refrigerator, it will cool the whatever the vegetables or anything. So washing machine doesn't cool the vegetables and the refrigerator doesn't wash the clothes. So it will do the perfect thing in a perfect way, like dedicated thing. If you are seeing a laptop, my laptop is doing different things, like it is sharing PowerPoint presentation and it is connected to the Zoom. So different things at a time it is possible. But if you have seen the keyboard, I can press keys and I can write the any word by using the keyboard. If you are seeing the mouse, I can use the mouse to move the cursor, but it will not perform more than one other task. So it will perform only dedicated task at dedicated time. So that thing is called as embedded system. So I already told you about the VLSI, whereas now coming to the embedded system, the perfect example is washing machine. So whatever the washing machine, if you're putting clothes but we don't observe the clothes what it is doing, so it will sense the automatic water level, it will keeps the water how much water it has to take. So everything the sensor will be there, and how much time it has to wash the clothes, so whether it is 30 minutes or 40 minutes. So ఎలా వాష్ చేయాలి, ఎంతవరకు వాష్ చేయాలి, and then how much water level it has to take, and how much cycle it has to be there, when it has to off the washing machine. So everything it has think and it will decide. So it is very important of an embedded system that it purposely built to one hardware to control specific task. So this is all about the embedded system. Now coming to the key characteristics of the embedded system. So it will do the dedicated function, I already told you, and real time operation. For real time operation, for example, the car is crashes, so then automatically in milliseconds the airbag is opening. So if the airbag is not open, the people in the car won't survive. So how it is doing? So it will based on the real time operation and low power consumption. So the embedded systems is running on low power consumption like batteries, whereas low power supply, and less size, compact in size, and high reliability. So these are all the main key characteristics of the embedded system which has to consider why these embedded systems are very useful. And yes, fundamental architecture. If you are seeing anything, there will be like three things. One is input, and it has to be processed, after then output. So the input is nothing but whether if you are want to sense the temperature, so how much temperature it is there. So if you want to take the values of temperature, then input is simple sensor, you will use the temperature sensor, and the process core is nothing but one micro processor. So the microcontroller is different from the microprocessor. See, whereas microcontroller will do one task at a time, like AC, air conditioner is a microcontroller, whereas microprocessor is, it will perform multiple tasks at a time. For example, if you are seeing my laptop, Intel Core i5 processor or Intel i3 processor, these are all the processors, AMD Ryzen processor. So these are the processor which is designed to perform several tasks at a time. But whereas if you are seeing the controller, those controllers will be designed to perform one specific task at one time. So coming to this a fundamental architecture, we have input, after then we have processing core, after then we have output. So inputs, for if you want to sense the temperature sensor is the input. Processor is, if you can take the Arduino Uno, some little bit of processors, those are very cheap, Arduino Uno, these are things. And the output is like you will get the display, whether if the temperature is more than 50 degrees or 40 degrees, the LED is on. So whether you are writing that type of code, the LED is the output. Otherwise, if you are thinking like whether the temperature is less than 10 degrees or 20 degrees, then the buzzer should be on. So the buzzer is the output. So here I have listed some of the inputs and outputs. So inputs is nothing but sensors, switches and interfaces, which is collecting the data from the environment. So if you are seeing the sensor, the temperature sensor or soil moisture sensor or different sensor, we have both like DHT11 sensor, humidity temperature sensor. So these are all comes under the inputs, whereas processing core is nothing but the microcontroller. Usually we have different microcontrollers and the output is like actuators, displays, buzzers and other devices which is comes under the output. So input, process, output, these are the three things you should have to remember the architecture. Next, coming to this essential hardware components. Yes, so the microcontroller and microprocessor, we have ARM Cortex microcontroller and AVR, Arduino Uno and PIC family, PIC families. We have different microcontroller. For us, heart is important, whereas if the heart is also responding, like if we want to pick some object with our hand or if we want to think, the brain is very important. For any hardware system and for any embedded system, the brain is like a microcontroller. So it is giving the instructions and it is manages the peripherals. So whereas coming to the memory systems, RAM and ROM are the memory systems, flash memory. So these are all things which is comes under the storage. So if you want to keep it some storage like data, if you want to store, so these are the essential things of memory. Next, input devices, I already told you, like sensors, all these things. Output devices like motors, LEDs and then buzzers, these are all things are outputs, comes under power supply. Power supply, we will be using very small power supply like batteries, like voltage regulators, so power management circuits, these are very small, not even we need more power. Whereas in VLSI we have required some more power, but whereas in embedded system it deals with the less power supply and less size. And coming to the embedded software essential. So we have now only we are thinking about what is the hardware required, what are the sensors required, everything we are thinking. But what are the software, what are the programming languages you need to learn to develop these embedded tools or embedded things. So then it will deals with the embedded C. So embedded C is not comes under the complete C language, but whereas it is similar, means the syntax and all those things it will be similar. So if you have one basic idea about the C language, then it will be easy for you to understand the embedded C. So to develop embedded software things, you need to learn the embedded C language. So this is a industry standard language, whereas coming to the assembly, like programming languages, and you need to know how you have to connect and how you have to dump the code in the actual hardware. So how you have to dump, like if you have done one code, for example, like I have to sense the whenever I am going out, the plants, it should need to be plant monitoring system, means automatically you need to put water to the plants whenever you are not there in a home, like if you went to any other festival or any something. So then you developed one soil moisture sensor, that whenever the soil is not having the humidity, so you will put it, then the water droplets it will automatically come. So you will keep one soil moisture sensor and humidity sensor. After then you have to code for those things, like how the soil moisture sensor will work and how the microcontroller I have to dump. So everything you need to connect, the assembly you need to know. And coming to the real-time operating systems. So this is the very important real-time operating system. So if you know, these airbag systems and ECUs, electronic circuit units in your bike, in car, these are all things we have ECUs. So these are the very important things which is known by the real-time operating systems. Next is communication protocols. So what is this communication protocols? I am like, my native language is Telugu, my friend native language is Hindi. So if I want to communicate with my friend, if I am not knowing the Hindi language, then I cannot able to communicate with that person. So I need to learn one common language which is known by him and by me. So I'll use the English to communicate with my friend, that he know already English and I already know English. So then the communication will happen. So in the same way, the embedded systems will only to be the communication. We have different communication protocols like UART protocol, SPI protocol, I2C protocol and CAN protocol. UART will be saying that Universal Asynchronous Receiver Transmitter Protocol. It is a simple serial communication protocol we are going to use to communicate between the device to device and device to computer connections. Whereas SPI protocol is used to it is called as serial peripheral interface. So it is also used to communicate with the microcontrollers, to sensors and displays and memories. So all these things we are going to use. Whereas I2C is inter-integrated circuit. This protocol is used to communicate with the sensors and low speed peripherals with the simple wiring, not too much of wiring. Whereas coming to this CAN, control area network, this is the most important protocol which is used for the automotive and industrial applications. So in a airbag system we are going to use this CAN protocol. Okay. Whereas coming to the types of embedded systems: standalone systems, real-time systems, networked systems and mobile embedded systems. So here coming to the standalone systems, like examples, cameras, whereas MP3 players and basic appliances, these are all comes under the standalone systems. Means that will just self-contained devices, it will only perform their function independently, means without depending on the others. If you are on the camera, it will not depend on the other object, or it will not depend on the other system to perform their job. So that is coming under the standalone system. Whereas coming to the real-time system, so these real-time systems will be usefully in the medical devices. So if you are seeing the heartbeat monitor system, whereas ECG systems, respiratory systems, so in medical devices we are going to use a real-time system, because it has to monitor the real time. Every second, every minute I have to monitor my heartbeat rate. So then I will use one sensor, that heartbeat monitor sensor. I use it to monitor my heartbeat for every second. So these type of things we are going to use in real-time system. Coming to the networked systems, so it will be useful for cloud integration, whereas IoT applications, and it will be like connected devices that communicate with other systems through the internet. So that is called the networked systems. So the thing is, it has to be the connection of internet. So that is why we will be calling as Internet of Things. Next, mobile embedded system. So yes, smartphones which is having the features of like fitness tracker, and how the trackers it is coming, how much you have walked, how many steps you have done, 5,000 steps or 4,000 steps. So in this mobile also there is an embedded system that is calculate. So if you have observed, you are walking or you are calculating, smartwatches also there. The smartwatches is also performing on this. So like how much steps you have done in one day, whether it is 5,000 steps or 4,000 steps, how much distance you have walked. So these are all coming under the embedded systems, mobile embedded systems. Fitness tracker, these are all things. So I have listed down some examples like AC remote, and then TV, and then micro oven, and washing machine, smartwatch. So whatever you are seeing, like these are all things you are surrounded by them, but you people are not even notice that okay, this is embedded system or this one. That remember that laptop is not an embedded system. Okay, whatever the features are in a laptop, separate keyboard is an embedded system, whereas mouse is an embedded system. So but laptop is not comes under the embedded system, but washing machine, micro oven, TV, AC remote, smartwatch, these are all comes under the embedded system. So when we are wake upping from the alarm clock, even the alarm is also embedded system. And whatever you are driving vehicles, cars, or else bike, whatever you are using, these are all comes under the embedded system. So by using all these things, our lives will be more convenient and more like it is like good, safe and efficient. So these are all things by using the man. But people won't notice in surrounding, okay, these are all comes under the embedded system, we are using it in a daily life, what is inside those, we have to learn. So that type of curiosity you have to build in your lifestyle, then only you can grow. Next, coming to the automotive embedded system. So yes, so let me give you an example. Whenever you are putting a hand onto the fire or else into the flame, you people don't think that at a time you will come out of your hand. So who will told that command? Our brain is telling that, nervous system is telling to that, giving command to hand, pull your hand back, because that is a fire, it will be leading to problem. So that is what car airbag system also it is going to work. When the car is crashes, the ECU in a car, we have 50 to 100 ECUs will be there. The ECU is nothing but electronic circuit unit. So this ECU will be communicate with that whatever the airbag system. That airbag system automatically opened within the milliseconds. So that is nothing but the automotive embedded systems. So we have dozens of embedded systems called electronic control units, ECU, each managing specific functions, performance, safety and comfort. We have engine control, after then we have airbag system, anti-lock braking ABS system, infotainment. So these are all will be working on this embedded system, whereas the monitor, it monitors, airbag system monitors whenever the crash sensor, there will be one sensor that whenever the crash sensor will be there, so then it deploys the airbag system within milliseconds of impact. So that is leads to our safety. Okay. Next, but these are all, if you are doing means, we have a complex embedded system, like whenever you are using in a car, audio system is there, you are calling in a car only, and increasingly volume, vehicle settings to the touch screen, whatever the touch screen is there, you are searching everything in a touch screen. So these are all things comes under the embedded systems. Next, yes, so embedded systems in IoT, building the connected future. So the IoT is nothing but Internet of Things. Let me tell you one example, that ATM machine. So if you are putting in card in a ATM machine, it automatically withdraws like 500 rupees, 1000 rupees. How that is working? So because of IoT. And whenever you are entering to the room, the lights will be on. Whenever you are exiting from the room, the lights will be off. Whenever you are entering to the washroom, the lights will be on. So whenever you are in an office, you will be telling to that fan or thing, so I am coming office from like 30 minutes in the time, so make sure that the AC should be on, so the room should be cool. So how is everything is possible? So this is possible with the IoT. For IoT, the embedded systems is the backbone. Internet of Things, we have the backbone of like embedded systems. Whereas this Internet of Things has the connectivity of internet. So without having internet, these things won't be possible, like smart home automation, smart street light. Smart street light is nothing but we won't switch on the street lights whenever the sun is not there, like the moon is coming at 6 o'clock, 6:30, 7 o'clock, when the light is not there, then automatically the street lights will glow. After then, whenever like morning 6:30, 7 o'clock, the lights will be off. So, and that is one thing. And coming to this, whenever the road, in an empty road, whenever the car is there, then only the lights will be off. Like if it is an empty road, the lights will be off. So like how it is going to be that? So these are all comes under the IoT. To develop the IoT, we have the backbone of embedded systems. We have to know the embedded system. So yes, the thing is, you have now coming to the basic idea that okay, we know what is an embedded system, what is an IoT, then what are the career opportunities in an embedded system. That is the most exciting question in the students. So if I have learned the embedded system, or if I have learned the IoT, then what is my career, or what are which job roles can I apply, and what are the companies they are hiring. So I already told you that will be like most companies are hiring for the embedded system, like product based companies like Qualcomm, and then this AMD. These are all things will be hiring for the embedded engineers. So the roles is like embedded software engineer and IoT engineer, automotive engineer, and firmware developer. So these are all things which is like you can search it in LinkedIn as well as you can search it in Naukri, that you can get these jobs and you can apply. But if you have to know some skills, then only you can apply. So what are the skills you have to learn means, the skills for this is C programming. You have to know the embedded C very well. After then you have to know the electronics fundamental. If you are from ECE and EEE candidate, maximum 50%, 60% you have basic idea that what is electronics and everything, but you have to sharpen your skills on the electronics and you have to apply. And debugging proficiency. Debugging is nothing but it is simple. Whenever you are getting error, you are the one, you have to rectify the error and you have to come across your mistake, means when you have done the error, so you have to rectify those. That is nothing comes under the debugging proficiency. Next, microcontroller expertise. So you have to learn some different microprocessor, not even the Arduino. So for example, if you are a college student, then you can aware of the Arduino Uno, but you have to learn ARM Cortex, AVR, ESP32 and ESP8266. These are all things, Wi-Fi modules. So everything you should need to learn the microcontroller. So if you learn more microcontrollers, then there is more opportunities for you. Like you can apply different jobs in different low level companies, high level companies, medium level companies also you can apply. So but these are all things, these are all the basics. First one is learning the microcontroller proficiency. Second one is embedded system, like embedded C programming. Next is electronic fundamentals. So if electronic fundamentals are there, then learning for these two skills is easy. Next, debugging proficiency, and the main thing is communication skills. So if you are enough confident to say the answer to the interviewer, then it is a cakewalk for you. Next, yes, Vision 2026, the embedded revolution. So what is this embedded revolution? Coming next 5 years, or you can see, we have electric vehicle expansion. Now only we have seen no one is preferred to use the petrol or diesel vehicles, means the oil type of vehicles they won't prefer. So we have in cars as well as Tesla, everything it comes under the EV vehicles. So whenever the EV vehicles is developed, so we are integrating millions of like chips. I already told you while we are discussing about the VLSI. But coming to this EV, we have auto sales as well as the ECU. Main thing is electronic control unit. So if you want to develop this electronic control unit, you have to be the embedded engineer, that you have to know about the how the battery management is going to work. So the most people will be designing one car or designing one bike, it is giving just for 100 kilometers of battery, after then again you have to recharge. So you have to be working on those things, you have to increase the battery time. So these are all the things that comes under. Nowadays that 12% of annual growth rate is there for embedded systems, faster than all over tech sector. Wherever if you have seen the software or any tech sector, so it is having more percentage there, the thing. And coming to the smart city infrastructure, whatever you are seeing now, gated communities, the people who are very interested to buy the homes in gated communities, they are having the desire that their home should be fully automatic with the fully smart home, like smart lights, smart fan and everything, smart control. With the mobile I should operate the fan, whenever I am there only the light should be on, whenever I am not there in a room the light should be off. So these are all things which comes under the smart city infrastructure. So this comes under traffic management and traffic rules. So these are all comes under this IoT. And I told you like 50,000 of jobs openings are there in this this sector, complete this sector. And smart devices, the demand is increases because the people get aware by this smart, using smartly. The people won't use the old things of type. because whatever we are wearable devices, let us take in some time we are going to use normal analog watches. Okay, now the people are very much interested to buy the digital watch like smart watch, so Apple watch, these are all things the people were very interested. So if they want to go for fashion and something, so 75 billion units globally, I am saying globally those people have bought and everything, it becomes some opportunity for the embedded engineers. So if the people want to wear the accessories, you have to develop, so the demand, it has to increase the 3 times of this embedded systems, particularly I can say. Yes, you are future in embedded system. I'll tell you one thing, this video may be attract to you that okay, these are all the things I can get job easily, but I'll say if you are more dedicated, then only you will get the job, whether it is in software industry or in an IT, like not IT is software is same, like in hardware, VLSI or embedded system. But if you are not consistent enough, then you then like 50-50 I will do, then it is, I will say, a big no. And if you are coming to the core technology, the foundation should be very good, like electronic devices, electronic circuits, and whatever you have learned in your BTech through like 30 subjects or 20 subjects. I am not saying you have to be pro in all the 30 subjects. There are some subjects like MPMC, microprocessor and microcontroller, digital electronics and analog electronics. So these are the some subjects you have to be pro in those subjects. And coming to the career excellence, so if you have entered as a embedded systems engineer, after getting 5 years of experience or 6 years of experience, your career should be very brighter among your family. Not only your family, you can give, like you can create opportunities and you can make one startup company by producing some electronic goods and everything. So wherever you are going with a knowledge, it is useful. So yes, thank you for listening this. I hope you got the clear idea about the embedded systems. If you want to know more details about the embedded system course, you can contact the phone number which is displayed here.